Hello everyone. So today we are going to start our new chapter and the name of the chapter is alternating current or we can say AC. Okay? So let us see what is alternating current and where it is used and how it is used. But before it, let us see what is DC. We have seen DC, that was direct current. Okay? That we have seen, that was direct current, and we have seen that the direct current that was constant in direction, it was not changing its direction. Okay, and its magnitude that also was constant. Okay, so the current which will not change its direction and its magnitude that also will remain constant, that is known as direct current. But if we talk about AC, then AC means alternating current. As the name of this current is alternating current. It means this current will change its direction and it may change its magnitude also. Okay. So, as we have seen in our previous chapter, which was EMI, there we have seen that how AC is generated, and we have seen that between north and south pole, if there is a coil which is being rotated with angular velocity omega, and this is the magnetic field from north to south pole. Okay, there we have seen that if we are rotating this coil, then the flux linked with this coil, that was NBA cos theta, and theta was omega t. So we can say that theta, that is NBA cos omega t. Okay, and when we will rotate this coil, then this flux will change. Okay, and because of changing flux, there will be an induced EMF E, and that will be d phi over dt, that we have seen. And after solving it, after differentiating it, we got NBA omega sine omega t, correct, that we have seen in our last chapter, which was EMI. तो और साथ ही साथ हमने पता किया था कि करंट करंट क्या था, E बाई आर. ओके, E was NBA omega, and here it is R, and here I can write sine omega t, and this quantity was representing the maximum value of this alternating current. So we can write it as I is equal to I naught sine omega t, correct. So here we can see that the alternating current that will have constant amplitude and it will change its direction. As we know that sine function will change its sign from negative to positive or from positive to negative after a certain time of interval. Okay, that we have seen. So what can we say? We can say that AC is the current which will have constant magnitude. It will have constant magnitude or constant amplitude, actually, sorry. It will have constant amplitude, not magnitude. It will have constant amplitude. And it will change its direction. Direction change after a certain time of interval. Okay, so that kind of current is known as alternating current. So now we can see some examples of alternating current. First is the simplest one, which is sine function alternating current. Here it is I and here it is T. Okay, from here to here we can see that it is completing its one round. So I can write here T and here it is T by 2. So here we can see that this current is changing its direction from positive to negative and then from negative to positive after a certain time. Okay, and its amplitude, that is also constant. Here I can write I naught, here I can write minus I naught. So this is an example of alternating current. Okay, but if we talk about this current, here it is T, here it is I, and the current is something like this. So here we can say that the amplitude is not constant. So we can say that it is not AC. Okay, although it is changing its direction, but its amplitude is not constant. If we talk about the one more type of current, here it is I, current constant, then it's changing its direction, then again it is changing its direction like this. So here we can see that the magnitude, that is constant from here to here. Okay, but it is changing its direction after certain time. Here also we can see it is changing its direction. So again we can see that the amplitude is constant and it is changing its direction after a certain time interval. So that's why we can say that is an alternating current. Similarly, we can say that if here it is T, here it is I, and this is the current, then here also we can see that the current is changing its direction from positive to negative, then from negative to positive, then from positive to negative after a certain time. Okay, and its amplitude, that is also constant. Amplitude is also constant. So that is an example of alternating current. Okay, I hope you got it. And now we will talk about the average value of alternating current, because here we can see that alternating current can change its magnitude, correct? So sometimes we will have to deal with the average value of alternating current. So let us see how average value of alternating current is find out. Okay, so as we know that if any quantity y, that is the function of x, then we can find out its average value with the help of integration y dx divided by dx, limits from x1 to x2, limit from x1 to x2. This will give us average value of y. Okay, similarly here I is equal to I naught sine omega t. This is the instantaneous current, this is the maximum or peak value of alternating current, and this instantaneous current that is changing with time. Okay, so here this current is function of time, so we can find out average value of this current. How? Let us see. So I average, we will write here I dt divided by dt. Okay, but as we know that the sine function that can be represented graphically like this. Here it is I and here it is t. So that is the graph of this alternating current, correct? Here it is I naught and here it is minus I naught. From here to here we can see that it is completing its one round, so we can say here it is the time period t, and half of it that will be here at this point t by 2. Now if we talk about the average value of this current from 0 to t time, then here we can say that the positive part and negative part both are equal. Okay, so we can say that from 0 to t the average value of this current will be 0, correct? And this thing we can prove with the help of this integration method also. But if you want to find out the average value from 0 to t by 2 time, okay, that also we can find out. But I would like to tell you one shortcut. With the help of that we can find out average value of this current very easily. And what is that? Actually here I am going to tell you that how we can find out the average value of sine theta, because here it is the sine function. Okay, so if we are able to find out the average value of sine theta, then definitely we can find out the average value of this current also. So if I ask you what will be the average value of sine theta from 0 to pi radian, okay, let us see. So from 0 to pi sine theta d theta, okay, like this, and divided by d theta, limit is from 0 to pi, that will give us average value of sine theta from 0 to pi. Okay, now if we solve it, we will get integration of sine theta, that is minus of cos theta. Limits are from 0 to pi. Here integration of 1 with respect to theta, that will be theta, and limit is from 0 to pi, correct? Now we will take this negative sign outside, and now we will put limits cos pi minus cos 0 divided by pi minus 0. Now if we solve it, we will get minus, here it is minus 1 divided by pi. So if we will solve it, we will get 2 upon pi. Okay, so average value of sine theta from 0 to pi, that is 2 upon pi. So we can say that if we want to find out the average value of this current, which is I is equal to I naught sine omega t, then the average value, that is the sign of average. Okay, I naught, that is constant, so its average value also will be I naught. And now average value of sine omega t, and here we are talking about half cycle. Okay, what will be the average value in half cycle from here to here of this sinusoidal alternating current? So as we have seen that the sine theta or sine omega t, that will have its average value as 2 upon pi. So here also we can write average value of this sine omega t, that is 2 upon pi. So we can say that average value, that will be 2 I naught upon pi. Okay, in this way we can find out the average value. I hope you got it. Okay, and now I am going to ask you that what will be the average value of this type of current. Here it is I, here it is t, and it is from 0 to t by 2, and then from 0 to, and from t by 2 to t, its value is 0, and then again it is sine curve, and again it is 0. So if we talk about from 0 to time t, here it is the time t by 2, then what will be the average value of this type of current? Actually this is the output of half wave rectifier circuit. Okay, so if this kind of current is given to you, then how you can find out the average value of this current from 0 to t? Okay, let us see. So for this we will have to take average value of this part and average value of this part. As we have seen that the average value of this part, that was 2 upon pi I naught, and average value of this part, that will be 0. Why? Because from t by 2 to t, the value of this current is 0. So average value of this current will be 0. Now first current, second current, and the time period is from 0 to t. Okay, so let us see. Here we can see that the time from here to here, that is t by 2, and time from here to here, that is also t by 2. So because this is equal time intervals, okay, so we can say that average value of this current, that will be I average, that will be I1 plus I2 divided by 2. So I1, that is 2 I naught upon pi plus 0 divided by 2. So from here we will get I naught upon pi. Like this we can find out the average value of this type of current. I hope you got it. Okay. Now let us take one more example. If we will have to find out the average value of a current which is changing something like this. From here to here it is t by 2, and from here to here it is t. Now its one round is completed. Okay, so and the amplitude of this current, that is I naught. Here it is t, here it is I. So if we want to find out the average value of this current from 0 to t by 2, then how we will solve it? How we will find out the average current? So again we will use the same formula, that is I dt divided by dt, limit of time, that is from 0 to t by 2, and here also 0 to t by 2, correct? But the problem is that first of all we will have to find out the function of this I in terms of t, time. Okay, so for that we can say that here it is a straight line, and we know that the straight line equation is y is equal to mx plus c. On y-axis we can see here it is the current I, m, that is tan theta, that we know. On x-axis we can see here it is time t, and because this line is passing from origin, so that's why we can say that intersection on y-axis, that is 0. So value of c is 0. Okay, now tan theta, here this is the angle theta, and this is perpendicular, this is base. Perpendicular is I naught, base is t by 2. So we can say it is I naught upon t by 2, correct? So that will be 2 I naught upon t, that is tan theta. So now we can write the function of I in terms of t, that is 2 I naught upon t into t. Okay, now we can put this value of, or the equation for I here. So I average, that will be from 0 to t by 2, and here it is 2 I naught upon t, here it is t into dt divided by dt from 0 to t by 2. Okay, now here we can solve it. So 2 I naught upon t, 2 I naught upon t, here it is t, so we can write it as t square upon 2, limit is from 0 to t by 2, divided by t. Why? Because integration of 1 with respect to time, that will be t, and here it is from 0 to t by 2, correct? Now here we can see that 2 and 2 cancelled out, and if we put the upper and lower limit here, then it will be I naught upon t, that will be t by 2 whole square minus 0 square divided by t by 2 minus 0. Solving it, we will get I naught upon t. Here will be t square divided by 4 divided by t by 2. So here t cancelled out, and here will be 2. So I can write here that average value of this current, that will be I naught by 2. Okay, so that is the average value of this current, I naught by 2. Okay, so you can remember it. And there is one more way to find out this average value. How? Because here we can see that this current is changing linearly. Okay, so if a function is changing linearly, then we can find out average value like that also. I average is equal to I minimum plus I maximum divided by 2. But this formula is useful only when the function is changing linearly. I minimum, here we can see that is 0, and I maximum is I naught. So I can write here 0 plus I naught divided by 2. So that will be I naught by 2. Okay. So in this way we can find out the average value of any type of function with the help of this integration method. Okay. I hope you got it. Thank you. Thank you very much.